Hello everybody, let's demystify some inventories. Just so you know, I am slightly sick. Hopefully all the sounds and gross will be edited out. All right, let's hop into this. First and foremost, what are we going to be doing? This is not a video series in order to let you build your own inventory system. You will have one by the end of the series, but let me explain what I mean. We're not just going to be saying, okay, plug A into B. No, we're demystifying. We're going to explain exactly what an inventory system is, what the parts are and why they're significant, how they communicate with each other, and really get into what an inventory system is, because I don't think a lot of people actually understand what's happening. So let's really start with the basics. What is an inventory system? It's a container that holds items. Okay, what is an item? An item tends to be a set of data put together to be something bigger than what the data would be split apart. Let me clarify. Let's say you have something like an iron dagger in Skyrim. Yes, it has a static mesh, but it also has stats, sounds, an icon, and a lot of other things associated with it, even the name. So an item is an accumulation of different parts put together. Then an inventory is something that houses all these different parts and can display it. So let's start by creating an item. Then we'll create an inventory that can hold said item. I am in a completely new project. It's first person. It does not have to be. Let's go ahead and create a new folder. I'm going to do underscore dark BPs. The underscore just puts it at the beginning of the alphabet. Then I'm going to create a folder called data. And within data, we're going to create something called a structure. A structure is a way for you to take different bits of information and make them travel around in a group. I don't know if you've ever heard of object-oriented programming. However, that's essentially what a structure is to a degree. It's basically saying, here's some attributes. I need them to follow each other around. I'm going to call it struct underscore item. We'll be very basic. We'll go ahead and save that and open it up. As you can see here, all it is a set of variables or data. So the first variable here, we can go ahead and just say this is going to be the name. For cases where we're going to be using an item, I actually think a string is better than the actual name variable. Has to do with how text is formatted. Don't worry about it if that doesn't make sense. You can use a name if you'd like. I'm gonna go ahead and add another variable. We're gonna call this static mesh. In fact, I'm not gonna put a space in there just for good naming conventions. And you'll never guess, we are going to do a static mesh object reference. We'll do another variable. We'll call this description. This will just be a set of text. So we have a name, a static mesh, a description. Let's go ahead and add an icon. So I'm gonna go ahead and just say it's an icon, and I'm going to make this a slate brush. We might change the slate brush later. I don't remember if I still use those or not, but for now we're gonna set it to that because I know that that's what I used at one point. And for now, this will be our item. I'm gonna go ahead and create a new folder. I'm gonna call it structures. I'm gonna go ahead and put my item structure in that folder. I'm gonna create a new one, and this one's going to be a data table. A data table is a place where we can take a struct we created and make multiple instances of it. It'll make more sense here in a moment if you are not following. So in miscellaneous, it looks like it is right here. We can go to data table. And as you can see, this is a list of the current structs. Obviously ours is here, struct underscore item. The rest of these are default in the engine. We're just gonna go ahead and use the one we created. And I'm going to use DT for data table underscore items, as that's the struct we use, and we're going to open that up. So you'll see this little window here. As you can see, there is a place for the row name, the name we put in, the static mesh, description, and icon. So what I'm going to do is I'm going to add a row to this data table, and you'll see here are the variables we put into the struct. So for example, we can call this dagger. I don't have a static mesh. I'll grab one in just a moment. The description will just say a short sword, which isn't entirely accurate, but it's fine. And I don't have an icon. Let me grab a static mesh and icon. Okay, so I imported this dagger icon. If you're wondering where I got that, that is from games-icons.net. You can use all these on their website for free, but they are Creative Commons 3.0, as you can see up here. So you do need to give credit. So this is by Lork. here is the icon I'm using. And then I'm using the low poly Viking world, which is on the Epic Marketplace. I got it for free during one of their deals, and I'll probably just end up using one of their props. So I'm gonna go ahead and just use WP Dagger 1 here. And for the icon, we have this slate here, so we can go ahead and select our image. I'm gonna be using the dagger icon that I got. And then of course I can set the image size, the tint, tiling, all that stuff, which all of that can just be default for right now. That'll come down to the actual widget side of the inventory, the display part. But for now, this will be good for the blueprint that we're about to create. It's all fine and dandy that we created a struct so we could set a certain amount of variables that travel around together to create an item. Then we used a data table in order to go ahead and create multiple items. In this case, we only made the one, but I'm sure you can see here how we could make multiple. And I just noticed, don't do this, I always forget. On row name, do not leave it row name. Go ahead and just name it whatever it is you name the actual item as well. They do need to be separate. I know it seems redundant, but we'll go ahead and hit save here. And we can go ahead and close the data table for now. Let's get a blueprint that can be placed into the world, so that way we can place that item somewhere and pick it up. So I'm gonna go ahead and open up my content drawer. I'm gonna go to Dark BPs. I'm gonna create a new folder, and this one's gonna be for actors in particular. We're gonna open that up. We're gonna create a blueprint class. We're gonna click on actor, and I'm gonna name this BP underscore item. I'm sure you could imagine. Save that and open it. First thing we need to do is we need to make sure that whenever we create an item or put one into our level, we can choose which item it's going to be, because right now it's just an empty BP. So we're going to need to use a combination of variables as well as the construction script in order to get this to work. Let's go ahead and create a new variable, and we're just going to call this item data. The variable type, we're going to go ahead and just make this a data table row handle, and we're going to make that a public variable by opening up that eyeball, and we're going to hit save and compile. Now that it's saved, we can mess with this variable. On the right hand side, the default value, I'm going to change the default data table over to our items data table. This is because this item is always going to be that data table, so it's okay if every single one of them is DT items. So we can hit compile and save. While there's not a lot of functionality yet, let's see exactly what it is we just did to keep things clear. I'm going to drag BP item out into the world. And on the right hand side, now you're going to be able to see that in default, because we made it public, we can actually see that item data. And of course, by default, we do know that it's going to be DT items. And if you look on the row name, we can actually select dagger from that data table. Now, obviously right now it didn't do anything, but we're going to make sure that it does. And I like it to be kind of a surprise, so I'm going to reset this back to none, so that way later we can set it to dagger and you'll see what it does. But for now, I'm going to go ahead and leave this out in the world and go back into our blueprint, where I'm going to add a static mesh. This static mesh is going to be nothing more than a placeholder ready to fill any static mesh that we throw its way. So I'm going to go ahead and just call this SM item, like such. Go ahead and save and compile. And this is where things get fun. What we're going to do is we're going to head over to the construction script. A lot of people don't know what the construction script is. The construction script makes BPs on the fly. And I know that sounds complicated, but it's actually really easy and really fun to use. And as you can see here, it's going to be extremely helpful. So what we're going to do is we're going to pull out our item data. We're going to go ahead and right click the pin, and we're going to split it. And whenever we split it, you're going to see that we have the data table and we have the row name. So what we need to do is we need to pull out of the construction script and hit get data table row, but not names, just get data table row, and go ahead and get that clicked. Now, I know your instinct is going to be to plug this in like this, right? Data table into data table. The reason you can't do that is because this is a wild card that basically well, it's not a complete wild card because that means it could be literally any variable type. It's a variable. There we go. This is a variable, which means if you were to plug this in here, it wouldn't work. As you can see, the out row is gray. It's like, bro, you could literally be any data table. I can't help you. But we know it's DT items. And now look, the out row is like, oh yeah, no, I know all about DT items. And then you can go ahead and put the name into the name. Now, what did we just do? Now, I actually skipped a step. So we need to move this over because we only want this to run if item data row name isn't empty. Because if it's empty, we know that they haven't selected anything. So what we need to do is we need to pull out of item data row name and type in exclamation point equal, and that'll mean not equal. So what we need this to do is plug this into a branch. By the way, to pull up that branch, I just hit B and clicked. In case you didn't know, it's a very nice set of hotkeys to know. So basically what we're saying is, hey, does this not equal empty? Because if it's not empty, it's true. And then we want to proceed to using the rest of the logic. I hope you can see why we did this, because if it was left empty and we tried to run this code, we would get errors. So this is simply just saying, hey, as long as they've set something, I need you to go forward. So if something is set, what we're gonna do is on this out row, watch this, I'm gonna pull it down and I'm actually going to break the struct and check it out. It's the exact struct we made earlier. We have a name, a static mesh, a description, and an icon. If you remember, that's literally the struct we made. And because now we have the data of specifically this row in this data table, we can take the static mesh and we can set the static mesh to the one that is defined in the data table. So with this set up, if we hit compile and save, we can go back to our world and check it out. When I change this row name to dagger, watch, boop, there's the dagger. So you're already starting to see how items are bits of information that travel together. Then an inventory is going to be something that can contain these bits of scattered information. I guess not scattered, they're quite organized. These bits of organized information and display it on a widget. But before we get to the widget aspect of the inventory, let's go ahead and create a very, very basic modular interaction system so we can actually pick the item up. To do this, I'm simply going to go back to the very top of our content folder structure. I'm going to open up first person and go into my first person character. What we're going to create is very much going to be intended for first person BPs, however, can absolutely be adapted to whatever controller you happen to be using. Just use critical thinking and adapt it in a way that is useful for you. I'm going to go ahead and on the left hand side create a new function. What I'm going to do is I'm going to call this sphere trace underscore reach length. What I mean by that is essentially whenever you call this, it's going to shoot out a sphere trace, whatever your reach length is set to. So I'm going to go ahead and create a variable that's going to be a float, and I'm just going to go ahead and call that reach length, and we'll save and compile. So what we're going to do is out of the sphere trace is what we're going to do is we're going to type in, well, sphere trace. And we want sphere trace by channel right here. So what we need is a starting position and an ending position on the line or sphere that we're going to use to trace. And basically don't let this be overcomplicated in your head. Sphere trace by channel simply puts two dots in 3D space and draws a sphere at whatever radius we tell. So like depending on how big the girth is, I said girth. Basically, we increase the radius, the higher chance it's going to hit something. So we need it to be pretty accurate since this is going to be the interact feature, right? Like what are we looking at? Shoot that sphere trace from my eyeballs, which will be the first point, to forward in 3D space, whatever our reach length is. Did we hit anything? If yes, send an interact request. I hope that made sense. Okay, so the first person camera is our eyeballs. So I just drug that out from the components. And what I'm gonna do is I'm actually just gonna get its world location. So get world location, and boom, look, we have our starting point because the camera is our eyeballs. So that's where we'll start. However, we have to do a little bit of math in order to get the endpoint, because we can't just take the get world location and add 200 to it and then all of a sudden we're at the endpoint. While that would be awesome, it's not that simple, but it is pretty close to that simple. Now what we're gonna do is, out of the first person camera, we're going to get the forward vector. The forward vector is a set of numbers that essentially tells Unreal Engine the direction that you're facing. It's from the direction that we're facing that we're actually going to multiply by our reach length. You'll notice this is another vector, but if we just take the reach length, we can plug it in and it will switch to a float. So we take the way we're looking and multiply it by the reach length, which I'm gonna go ahead and compile and save and set the reach length to, I don't know, something decent. 500 works for me. Compile and save again. And we're saying, hey, we're looking this direction, 500 units. So what we just did is we set a direction and a length by multiplying it by the reach length, okay? So now from 0, 0, 0, it is choosing a direction and going forward 500 because that's what we set. However, we don't want that from 0, 0, 0. We want it from our current location. We have to add the world location to this vector. So I'm just gonna pull it out and hit add. And we're gonna take the world location, add it to this vector, and plug it into the end point. Very quick recap. Our eyeballs, first person camera world location. That's where we want the first point. Remember, this is the first point. To get the second point, we look at, we from 0, 0, 0, we see what direction we're facing, and we multiply it by the reach length. Now remember, that's not creating a line. That's simply moving the second point, because the first point is our eyeballs. It's moving the second point from 0, 0, 0, reach length amount in that direction. So by adding the world location, we're saying from the world location, get our forward vector, go forward 500 units. And that's what the multiplication is. That's the end point. If that was complicated, don't worry. I'm going to give you a visual representation in a second. Our radius, we don't need it to be anything huge. I'm just going to do 10 for now. And we're actually going to turn the draw debug type on. I'm going to, you don't have to, and I'll show you what it is here in just a moment. But for duration, so that way we can see what it's doing. And then what we're going to do on this function is we're going to do an output. So we're going to go ahead and click on this sphere trace reach length. And for output, I'm going to hit plus, which should give us a nice little return node here. We're going to plug in the return node. Yes, these are both Booleans, so I could plug that straight in, but it's easier and quicker because it'll copy the name over if I just delete that out of the return node, then drag the out hit in, boom, and drag the return value in. So that is the sphere trace setup. So let's go ahead and hit compile and save. Now what we're going to do is we need a way for the player to actually be able to call this sphere trace. So in order to do that, I need to go over to the input folder, and on the IMC, and then we're going to go into actions, and we're going to create a new input action. So I'm going to right click. I'm going to head up to, oh, where is it? Input, and I'm going to click on input action. We're going to call it IA for input action underscore interact. We're going to open it up. We can leave this exactly the way it is because the value type is a digital bool. That basically means it's either on or off. Well, whenever we're interacting or pressing a button, the button's either being pressed or not pressed, so therefore digital bool is perfect. Now we'll head back one in the folder, and we're going to go to the IMC default, which means it's not going to work if we pick the gun up, but I'm not going to pick the gun up. Under mappings, I'm going to go ahead and make that bigger, and then I'm going to add a mapping. And you should see the interact that we created in there. Then I'm going to open up the interact here, and then it's saying, hey, what key? So I'm just going to click on this little keyboard here and press F, and now F is set to interact. Head back over to our first person character. And now in the event graph, what we can do is if we right click and hit IA underscore interact, you'll now see there's two we can pick from. There's enhanced action event, and then there's a value. We want the event, which will give us this nice little red box. This is basically what's gonna happen. This triggers whenever they press whatever button we set. I like to use started. Triggered means that if the keyboard has rapid fire, which a lot of keyboards do, like for example, if you go to type, so if I went to type in this comment and I hit A, that's every single one of those A's was a trigger. So I just like to use started, so that way it's like, boom, they hit it, it started, just the one time. I don't need 100. So on started, we're gonna go ahead and do that sphere trace function we created. So that will call the sphere trace reach length, and now we have an out hit and a return value. We're gonna hold B and click to get a branch, which will let us know if it hit anything, because if it doesn't hit anything, we don't care, right? So if it does hit something, we need to do a quick check for something we haven't created yet. We'll get to that in a second. What we're going to do is we're going to type in does, oh wait, you can't pull out a true for this. Just right click on the graph. Does implement interface. And right now we don't have the interface, so we're going to leave this be and go make the interface real quick. So what is an interface? An interface is basically just something that has a bunch of functions that multiple blueprints need to be able to do or react to. And it's kind of like a contract. Whenever you implement an interface onto a blueprint, it's saying you need to know what to do when this happens. The reason I describe it with such finality and conviction is because it's really easy to mix up interfaces and event dispatchers because they both serve very similar purposes. But that's not what this video is about. Just know that an interface is a contract on a blueprint to say, hey, I know what to do whenever this happens. So I'm going to create a new folder and I'm going to call it interfaces. We're going to go ahead and open that up. We're going to right click, go up to blueprint, and there should be a blueprint interface right in here. I'm going to call this a BPI underscore interaction. Go ahead and save that and open it. So you'll notice that when you open it, it's immediately like, hey, new function. As I said earlier, it's just a set of functions that you're going to be able to put on multiple things, and they're all going to be able to be like, oh, I do have a definition for what to do when this happens. So what we're going to do is we're going to go up here, we're going to click on new function. If it doesn't immediately rename, just hit F2. I'm going to call this interact request. And what I'm going to do is include a input of the interactor. This will be an actor object reference. Then we're going to create an output and just call it success. And that will be a Boolean. So the reason you send the interactor and or have the option to send the interactor is in case whatever is reacting to the request needs to know what's doing it. For example, if it was multiplayer, which character is doing it? And then the success is, of course, just for debugging purposes and making sure your game doesn't crash if you need something to succeed before you continue. Right now, I know this seems really simple but complicated because it's like, what does this even do? Hold with me. Let's go ahead and compile and save that. And now what I'm going to do is click back on our BP item. And for now, just go up here to the class settings. And on the right-hand side, you'll see we have the implemented interfaces. We are going to select the one we created, which of course I do BPI, and then there is our interaction. And we're just going to hit compile and save. We will go further into detail as to what is happening in just a moment. But I don't want to get too far off what we were doing. Remember, we're drawing a sphere forward, and then we're checking if it hits something. That's where we're at. Okay. So what we need to do now is on this out hit, pull it out, and we're going to just break it. So that way we have all the details. Now, when you open this, it's overwhelming and large, but luckily once we pull out the pin we need, we can recollapse it. Okay. So what we need is the hit actor. Does this actor implement, and this is where we check if it implements the interaction, the BPI interaction we created. Now we can recollapse this for now. And I like to just make this nice and straight. And then we do another branch, hold B, click. So yes, we hit something. And then, does it have the interact interface? If yes, this is where we can actually have communication between blueprints using the interface. Remember whatever it was called? It was called interact request. So we're going to type in interact request. And you'll see that in parentheses it says message. So I'm going to go ahead and click on that. And as you can see, it needs a target, which we know is going to be the actor that was hit because we just did a test and we know that it has the interface. And then it needs the interactor, which in this case, just pull out and do self. And we don't need to check for success. Sometimes you do, sometimes you don't, but for now, we don't really need to. So let's go ahead and hit compile and save. And this is our interaction. Compile and save. So if this worked how I think it should, when we go into the world and I hit F, you'll see we drew a sphere forward from our location forward 500 units. And if it hits something, it will tell us. It'll be like, oh, hey, I came across something. And it's going to check and see if that thing it comes across has the interact request on it. Or, yeah, the interact request, the BPI. I'm going to go ahead and turn off that debug trace now. Okay, so what in the hell is the interact request or the interface even doing? Remember, we implemented it onto the item and I just left it at that. And then we checked to see if it had it, and then we're like, it does, and then we were all happy. Why? Well, because now that it is implemented, on the left-hand side, you'll notice that we have, under interfaces, an interact request. If we open it, look, this is what we set up earlier. We can define what happens now whenever it receives that message. So for example, I'm gonna go ahead and just pull out from the interact request. I'm gonna do a print string. And it's simply going to say hello, that's fine with me. And then we'll return a true because it was successful, and we'll hit compile and save. I'll be honest, I don't know if this dagger has collision. If it doesn't, this isn't gonna work. Let's test real quick. Aha, but look, it does have collision. And you know it has collision because I'm hitting F, which is the interact request. Remember what the interact request is defined to do on this specific item? That's right. It's meant to print string hello. So it's receiving the message via the interface that is being sent because we're line tracing forward, checking if we hit something. If it has the interface, then send it a message that says, hey, we're requesting interaction. Then within the item on the left-hand side, we've defined a reaction. Here's the interact request coming in. There's the print string, return success. I know this isn't supposed to be about interaction, but unfortunately, picking up the item is important to an inventory system. Inventory systems are very complicated and there's going to be a lot of information, which is why this will be the end of part 1. I apologize, but I don't get paid to make YouTube videos, but I'm trying. I'll get there one day. But for now, I have to end part 1 here. If you have any questions, let me know. Part 2 will be coming very soon, and I'm excited to announce a podcast about indie game development is in production by me and a really nice collaborator, and I cannot wait to let you guys get your hands on it. But for now, like, comment, subscribe, and I will see you back for part 2 of demystifying inventory systems.